Right. Okay. Right. Now let's see what you are given. An aeroplane flies to its destination 300 kilometers directly east of its starting point. The pilot wants to complete the flight in 50 minutes. A wind blows in a northeastern direction at 10 meters per second. Now, we are only given one velocity here, and that is VW, right? They said VW is 10 meters per second. Its direction. Now, they said a wind blows in a northeastern direction. So, because the wind direction is given from the perspective of where the wind is headed, right? It means we're going to use the wind direction exactly as it is because it is given from the perspective of where it is headed. If they said that the wind, or if they say that the wind is going in that direction, then you use the wind direction exactly as it is. It's only when the wind vector or the direction thereof is either unclear or they straight up said it is coming from the given direction. Right. So if the wind direction is given from the perspective of where it is coming from, then you use the direction opposite what you are given. Right. Now in this case, they made it simple for us. They gave us the wind direction from the perspective of where it is headed. So we use it exactly as it is. That is northeast. Northeastern is the same as north 45 east. So this is north 45 degrees east. Right. We are given the wind vector. That's the only vector we are given. Now, because the only vector we are given is expressed in terms of meters per second, that is an indication that you need to express all your other vectors in terms of meters per second. I will clear.
Yes, yes.
Yes, sir.
Right. Now, let's see what else we've been given in the statement. Right. They said an aeroplane flies to its destination. Right. Now, anything that has to do with destination, anything that has to do with displacement, anything that has to do with time, right? All of it is for one vector, and that is the resultant velocity. Right? So anything that has to do with destination, displacement, and or time has to do with resultant velocity. Right? Meaning that if they say that an aeroplane flies to its destination, so you have the term destination, they also give you the displacement directly east. Right? So the destination is directly east. Remember that everything that has to do with destination, displacement, and or time has to do with resultant velocity. So this being the destination or the direction of the destination means that this is the direction of VR. All right. So from the statement, we have the direction of VR. We do not have the magnitude of VR, but we have its direction, and its direction is directly east. Are we clear? Hello.
Yes,
Yes,
sir.
sir.
Yes,
Right.
sir.
All right. We haven't been given anything regarding VO. Right. Now let's represent our vectors on the Cartesian plane. Right. That's our Cartesian plane. There. Right. So of the two main vectors, we only have information or all the information for the wind vector. They said the wind is 10 meters per second in a direction north 45 east. North 45 east is in the first quadrant. Right. So we have, say, 10 meters per second going in that direction. Right. This is VW, which is 10 meters per second. right? Now, as much as we do not know what is this, the magnitude of VR, right? But with the Cartesian plane, the most important thing is the direction, of which we do have the direction of VR. And they said VR is directly east, meaning that whatever its magnitude, it is headed east. So this is headed in that direction, right? This is the magnitude of VR, or this is the vector for VR. It is headed in that direction, right? Now, to complete the vector diagram, right? The vector diagram, if you're using the parallelogram, right, it has to have 4 sides. But if you're only using the vector diagram using the triangle, it is going to have 3 sides, right? Now, a triangle, right, has 3 sides, and each of the sides represents a vector. 2 of the main vectors, which is VW and VO, and then the other one is VR. Now, if you look here, you already have 2 sides, right? To complete the vector diagram, it means you just need to connect the 2 vectors. Do you see that? Hello?
Yes,
Still
sir.
here, sir.
Yeah, so when I want confirmation, people must give me confirmation. Okay. Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir. Yes, sir.
So to complete the vector diagram, we know that we simply need to connect the 2 vectors, hence completing the vector diagram. Right? Now we know that this represents VR. We know that this represents VW, which means this represents VO. Right? And what we know as far as direction is that VW and VO must always follow a head to tail direction. Now, as far as head to tail, this is going in that direction. So for this vector to follow a head to tail direction means that it has to go in that direction. Do you see that?
Yes, William.
Yes,
Yes, sir.
Yes. Right.
Yes, sir.
So we know VO is going in that direction. Right. So for VO to be in that direction, in which quadrant must it be on? So the question is, we've already established that VO is going in that direction, right? Now, if we were to place, right, VO in one of these quadrants, in which quadrant would we need to place it?
Northwest.
Northwest is here. If you take this and you place it there, see, it doesn't compute. Remember that
No,
each
sir.
of the
No,
No, sir.
in the
That
fourth
sir.
quadrant, sir.
That's southwest. That's
The
southwest,
fourth
sir. I
quadrant.
said
In
northwest.
the fourth quadrant.
even northwest doesn't compute. Remember, our vectors cannot be going towards the center of the Cartesian plane. So still, this does not compute.
southeast. Southeast, sir.
Southeast.
Exactly.
Southeast.
This will need to go there, which makes sense because if you were drawing the parallelogram, then this is what you do, have this there,
Oh, okay.
and your parallelogram will be complete, right? So this is to say that VO is going in this direction. Do you see that? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Meaning
Yes,
that,
sir.
meaning that since we've established that VO is going in this direction, hence in the 4th quadrant, it means we would need to get this angle, right?
Yes.
Hello?
Yes, sir.
Do you see that? It seems like I'm speaking to one person. If you don't see it, just say so I can explain.
I did it with analytical
We
methods.
start with you, sir.
So you use the method of components.
Yes, sir.
All right, that's fine. That's completely fine. If you use the method of components, right, it means this is where you have your VO. In that case, you would have had to establish a scenario asking yourself, if the destination is directly east, how would the pilot need to fly the plane, right? Taking the wind into consideration, right? Or taking the wind direction into consideration, such that however you fly, you end up directly east after flying 300 kilometers per hour. I mean, after flying 300 kilometers, right? And the answer would be, because the wind is pushing you in that direction, you obviously wouldn't fly in that direction. Nor would you fly in this direction, because the wind would push you to that direction. So you'd end up somewhere in this quadrant. So meaning that to counter the wind, you would have to fly in that direction. That way, the wind would still push you in this direction, but now it would be pushing you back to course. Do you see that?
Yes, sir.
Yes, sir.
So this is for the guys that used the method of components. That is how they would have needed to look at it in order to establish where the VO vector would have to be in order for the pilot to end up directly east. Right. For the guys using the vector diagram, right, this came out on its own. Right.
Yes, sir.
Right. So if VO is in this direction,
Yes, sir.
it means we are going to need to calculate this angle. Right. This angle is exactly equal to this one there, or that one. So meaning, if you are able to calculate that angle, right, you inadvertently calculate that angle. Right. Now, which angles do we have here? They said VO is north 45 east. So that angle is 45 degrees. Right. Now, based on what you've been given, remember I said destination, displacement, and or time, all of that has to do with VR. Right. They've given us the displacement. They said it's 300 kilometers. They also gave us time. Time t is equal to 50 minutes. Right. Now we are able to use this to calculate VR. Right. How do you calculate VR? Right. V is equal to S over T, displacement over time. Right. Now remember, the only vector of which we have the magnitude for is expressed in terms of meters per second. So any and all vectors have to be expressed in terms of meters per second. So that is to say, we have to convert the kilometers to meters. To do that, you simply multiply this by 1,000. So this will be equal to 300. Right? To convert from kilometers to meters, you multiply by 1,000 divided by, right, the time we're given is in minutes. We need to express the time in seconds. Now, how do we convert from minutes to seconds?
Dividing it by 3,600.
Nope.
Times it by 60.
There is
3,600.
Remember,
Divided by
times 60.
3,600.
remember that
You
No,
times it by
times by
60.
60.
Yeah, you
Yeah.
times it by 60.
equals 60 seconds. 1 hour is equal to 60 minutes. 1 hour, therefore, is equal to 3,600 seconds.
Yeah.
Right. Now we are given
3,600.
the time in minutes. So meaning this is what we have, this is what you're looking for. Right. So because this is what you have, from here to there, you simply multiply by 60.
60.
Right.
Okay.
1 minute is equal to 60 seconds. Right. So to convert from minutes to seconds, you simply multiply by 60. Essentially, what you have here is that's 50 times minutes. 1 minute is equal to 60 seconds. Right? So all you are doing is you are replacing the minutes with seconds. And in 1 minute is represented by 60 seconds. All right, so all you do is getting rid of this and using the seconds instead. Do you see what I did there?
Yes, sir.
All right.
Yes, sir.
And then what do you get here? What is this equal to?
100 meters.
100.
100.
100 meters per second.
Meters per second. Right. So this is made a mistake that I was supposed to say VR. So anything that has to do with destination, displacement, time has to do with the resultant velocity. Right. So essentially we have the magnitude of the resultant, which is 100 meters per second. Right. They want us to calculate the velocity of the aeroplane. Right. The velocity of the aeroplane is VO. So they want us to calculate VO. So in order to do that, so here I'll be using the vector diagram. So here we will have coded A, coded B, coded C, meaning small letter B, small letter C, small letter A. All right. And then we establish the angle we have. Is it an included angle? Say something.
Yes.
So our angle is an included angle. Why? Because it is between two known vectors. We know this vector and we know this vector. So seeing that this angle, this is the angle we have, and it is between two known vectors, it means this is an included angle. So it means we're able to use cosine rule. Right, using the cosine rule, say A squared is equal to B squared plus C squared minus 2BC times cos A. Right? A squared is equal to, what is B squared equal to? B is 100 squared plus, what is C equal to? 10. 10 squared minus 2 into 100 into 10 times cos A. A is 45 degrees. Right? And what is A squared equal to? Remember that here we are going to have to use the square root of all of this. So this being equal to A squared, what is this equal to? What is the A squared equal to?
8685.786.
Second,
8685.786.
8685,
Yes. 786.
786. And then of course, we calculate the square root of this, and what do you get?
93,198.
93,198.
Yes.
198, this is in meters per second. Remember that small a represents VO, therefore meaning VO is equal to 93,198 meters per second. Right? So that's the magnitude of VO. Right? That's the magnitude of VO. So because they want us to calculate the direction of VO in the second question, right? We don't calculate it here. We leave it for 1.3.2. Right? For 1.3.2, that is where we need to calculate the direction of VO. Right? So the direction of flight is, what is the direction the flight would need to take, right? Taking the wind vector into consideration, right? For the pilot to end up directly east, right? And as we've established, This is the direction of flight. Hence, we need to get this angle. This angle is the same as this one, so we just need to calculate that angle. As calculating that angle, you simply use the sine rule.
Sine rule.
All right, you use the sine rule where you're looking for sine C. It's this divided by side C. The angle you have is angle A. Sine A divided by sine A. That's angle A. This is equal to arc sine of.
Sorry, sir. Can someone please put off the mic? I can't hear sir properly.
Okay, let me sort that out quickly. Oh, it seems they switched off their mics. Okay, nice. Right. So arc sine C times sine A divided by side A. Right. And what is this equal to? So this is arc sine of right. So C, side C is equal to 10. So this is 10 sine A, which is 45, divided by side A. Side A, we just calculated and got 93,198. And what do you get here? What is C equal to? The angle C. What is this equal to?
4,351.
4,351.
Yes.
351 degrees. Right. Now we had already established that this angle is equivalent to this one. Right. And then once you have this angle, right, this angle is referenced from the x-axis, and we know that VO is in the fourth quadrant. Right. So meaning that the direction of flight is equal to, the angle is referenced from the x-axis, and if the vector is in the fourth quadrant, it means the x-axis are east. So meaning this angle is referenced from east. The angle is 4,351 degrees. It's in the fourth quadrant, meaning that's south. Easy does it. Any questions?
Sir, could you please show it if we were to use the component method?
Components.
Yeah.
So if you're using the method of components, right. So if you're using the method of components, right, so here are vectors, right, and then we say, because two of our vectors are oblique, so you'd have to resolve those into its components. All right, so when you resolve this into its components, we're going to have this component as well as that component. So the components of VW in the x direction is equal to, now this is headed east, and VW is equal to 10. So this would be 10 cos 45. And then the y component of VW, seeing that it is headed north, is positive 10 sine 45. Right? Now for the component of VO. Right. This one is headed in this direction and that direction. So the components of VO would be as follows. This would head in that direction, this one in that direction. So VO in the x direction, right, it is headed east, so it is positive VO cos. Now this, let's say we name as theta. So this would be VO cos theta, right? And then VO in the y direction would be equal to negative, because it's headed south. So this would be negative VO sine theta, right? Right. And this here is VR, as we've established. So remember, at this point, you wouldn't have known what VR is equal to, but you'd essentially do the same thing. Calculate VR using this, and you'd come to the conclusion that VR is equal to 100 meters per second. Are we together there? Hello?
Yes, sir.
Yes, sir.
Right.
Yes, sir.
Now, in this case, we have two unknowns. We don't know VO and we do not know theta. Right? Two unknowns means two equations, of which if you apply conditions of equilibrium, you are going to have two equations. Right? So applying conditions of equilibrium now, you'd say the sum of V in the x direction is equal to VO in the x direction plus VW in the x direction. Now, the sum of Vx, remember that the sum of Vx and the sum of Vy, those are components of VR. Are we together here? Are we in agreement?
Yes, sir.
Right. The sum of Vx and the sum of Vy are both components of VR, the resulting velocity or the resultant velocity. Right. Now, if you look at VR here, we are told VR is directly east, meaning that it is parallel with the x-axis. Now, what does that tell us? The fact that VR is parallel with the x-axis tells us that, right, it tells us that the component of VR in the x direction is approximately equal to VR itself, right? And that the component of VR in the y direction, so sum of Vy, is approximately equal to 0. Right? That is what this tells us. The fact that VR is parallel with the x-axis, that means it is not oblique. Because it is not oblique, we would not need to resolve it into its components. The fact that it is parallel with the x-axis, right, tells us that the component of VR is approximately equal to VR. I mean, the component of VR in the x direction is approximately equal to VR. And that the component of VR in the y direction is approximately equal to 0. Are we together here?
Yes, sir.
Yes, sir.
Yes, sir.
Right, so are we sure we're together?
Sir,
This is important.
sir, if
Yes.
VR is it's parallel to
to y-axis, it's gonna be the other way around.
It's gonna be the other way around. If VR is parallel with the y-axis, so let's just say they said it's going directly north, right? So it could have been headed south, but let's just say it is headed directly north. So say VR was parallel with the y-axis, right? That would mean that seeing that VR is parallel with the y-axis, meaning it is not oblique, this would then mean that the sum of V in the x direction, so the component of this VR in the x component is equal to 0, and the component of VR in the y direction is approximately equal to VR. Are we clear?
Yes, sir.
Yes, sir.
So I need that guy who was asking the question to confirm if we are clear here.
Yes, sir, we are clear.
All right. Very good question. Right. So the fact that VR is parallel with the x-axis means that the component of VR in the x component is approximately equal to VR, and the component of VR in the y direction is approximately equal to 0. Right? So that is to say sum of Vx is equal to VR, and seeing that we've already established that VR is equal to 100, it means this is 100 is equal to VO in the x direction, which is VO cos theta, plus VW in the y direction, which is positive 10 cos 45. All right. Then from here, simply transpose this to that side. All right. When you transpose that, you are going to have VO cos theta is equal to 100. When you transpose this term to that side, it becomes negative 10 cos 45. All right. Take this as your first equation. Now to get your second equation, you again apply conditions of equilibrium. Sum of V in the y direction is equal to VO in the y direction plus VW in the y direction. All right. Now we've already established that seeing that VR is parallel with the x-axis, it means the sum of VR in the y direction is equal to 0, or approximately equal to 0. So that 0 is equal to VO in the y direction is negative VO sine theta plus VW in the y direction, which is positive 10 sine 45. Right? Now to make this simple, take this term, transpose it to that side. Once transposed, it becomes positive VO sine theta is equal to 10 sine 45. Right? And then you take this as your second equation. Right? Now, I'll explain a much simpler way of doing this. Once you get to the number of equations, it's simpler because you won't have to create a third equation, right? As things stand, we need to create a third equation that will then substitute in one of these equations, right? Now, if you look at both of our equations, right, our equations are in terms of trig ratios. This is in terms of cos, this one is in terms of sine, right? We obviously, cos and sine do not cancel each other out, right? So we need to manipulate, or we need to create a third equation, and that third equation must be such that when we substitute the third equation into one of these equations, right, we are able to get tan. Are we clear? There are two trig ratios that incorporate both cos and sine, right? It is cot as well as time. This one is obviously not on your calculators, but you do have this one on your calculators. That is why in creating a third equation, you must create it such that it is convenient for when you're substituting your third equation into one of these equations, right? And when you substitute, it must be such that you essentially have sine over cos. Remember that tan theta is equal to sine theta divided by cos theta. So this is what you are looking for in substituting the third equation. Right? Now, what does this tell you? This tells you that your third equation must be such that that denominator is what? Is cos theta. Right? Now, between the two equations, which of the two equations can you manipulate such that cos theta is the denominator?
Number 2.
If you manipulate this one, you are going to divide by sine both sides. So meaning sine will be the denominator. You want cos theta to be the denominator.
So it will be the first one, sir.
It will be the first one. Yes. Right. Remember that in substituting the third equation into one of these equations, you must make sure that your third equation, right, the denominator thereof is cos theta. And between equation 1 and equation 2, it's equation 1 that will have a denominator as cos theta. Why? From the first equation, we are going to divide both sides by cos theta. It's going to cancel this side, and then this side you are going to have 100 minus 10 cos 45 divided by cos theta, which is exactly what you're looking for. Are we together here?
Yes, sir.
Where are the others?
Yes, sir. But to be honest, sir, your first equation was much better than this one.
The first, the first
Yes, sir,
approach.
that one is much. Yes, sir, it's much easier to grasp and
R-
apply compared to this one.
Remember, I told you. with
So
multiple
shouldn't you divide by cos to get 10? That's why using the second equation.
So both of the things you said cannot be true. You said, shouldn't you divide by cos to get 10? The answer is yes. But in order to do that, we cannot use the second equation. We have to use the first one. So let us do this practically. Right? Take the first equation, right, to formulate a third equation. Right? This is your first equation, right? Let's take it exactly as it is. Right? Now to formulate a third one, we are going to divide both sides by cos theta. That cancels, therefore meaning VO is equal to 100 minus 10 cos 45 divided by cos theta. And this becomes your third equation. Now, once you have your third equation, remember that we manipulated the first equation, so we can only substitute the third equation into the second. So now we say substitute the third equation into the second equation. The second equation is, all right, so this is your second equation. That's your second equation. Now substituting the third equation, which is this, into that, now we say, instead of having VO here, we are going to express VO in terms of the third equation. So here you will have, this will be 100 minus 10 cos 45 divided by cos theta. Right, so remember that this whole term represents VO. Right? This term represents VO. But in the second equation, it's VO times sine theta. So you say here times sine theta is equal to 10 sine 45. Do you see that?
Yes, sir.
Right? Now, once that is done, remember that this, you are able to say, right, this is the same as mathematically as that. Are we in agreement here?
Yes, sir.
Hello?
Yes, sir.
Yes, sir.
Right. And then once you do this, we know sine theta over cos theta is equal to tan theta. So this is the same as saying tan theta times this term times this. Is equal to 10 sine 45. We are looking for theta, therefore you divide both sides, right, by this term. Right? Obviously this and that cancel. And then in calculating theta, this will be theta is equal to arctan of this term. Right. And see what you get here. What is theta equal to? Right. The theta that you should get should be the same as the one we got when we took the vector diagram approach. What do you get here?
Get the same, so it's 4,351.
351 degrees. Right. So you have theta. Once you have theta, remember that for 1.3.1, right, you are looking for VO. So calculating VO, you simply substitute theta here. All right. So to calculate VO, VO is equal to 100 minus 10 cos 45 divided by cos theta. Theta is 4,351. What do you get here? Hello?
93,198.
93,198 meters per second. Right. At this point, remember we had already established in which quadrant VO is going to be in. Right. So that means when calculating the direction, right, the direction would be, seeing that we've already calculated the angle. We know that VO is in the fourth quadrant and the angle is referenced from the x-axis, meaning that this is east 4,351 degrees, fourth quadrant south. Right. Using the method of components, this is the approach you would need to take. That is why I told you for resulting velocity, right, the best approach is the vector diagram. Do you see why I say that now?
Yes, sir, very much.
Yes, sir.
Exactly.
Sir, can I ask you a question?
Yes.
Can you please send us the formula sheet so that we can know which formulas will be on and which we need to memorize beforehand?
Okay, I'll send you the formula sheet. But to answer the question quickly, you need to know all of them. The formula sheets for engineering
Okay,
science is
sir.
1 page, and that formula sheet isn't that helpful, to be honest.
Okay, sir.
But I will
Thank you.
send you. I will send you the formula sheet.
Thank you.
So can we do one more activity before we move to projectiles, please?
The other ones you need to do on your own. We need to move on to
Okay, sir.
projectiles. I'll still be able to help you, but I mean for this session, we need to move on to projectiles.
Okay.
So I got the same answers, but I didn't use sin, cos, or tan.
What do you use?
But I only made I only used the wind vector and the resultant vector to get to the answers. And it's very simple on
What
I
did you use?
My first equation was the sum of Vrx is equals to Vax plus Vwx. And then I got 100 is equals to Vax plus 10 sine 45. And then I made then I got Vax is equals to 100 minus 10 sine 45. And then I got Vax as 92,929 meters per second east.
You
And
got VAX as 92.
yes, 92,929.
Okay, you know what? Just send it to the group.
Okay.
Just send it to the group so we can all see it. Nah?
Okay, sir.
All right, sure. Right, so familiarize yourselves with the vector diagram, people. It's much easier to use. Or maybe not much easier, but less tedious. That's for sure. Right. Now, with everything we've done up to so far, you should be able to attempt any and all problems based on resultant velocity or resulting velocity. Right, but I'll still be available to help if you still need my help. Nah?
So I send it in the group. You can have a look there.
Uh, mm, okay. Okay. Yeah, I like this approach. I've never thought about it. All right, everyone can see it in the group.
So I actually used the same method and got the same answer, basically. So it does work. I thought that method was incorrect because it wasn't the same as the answer on the question paper.
It wasn't the same as the answer on the question paper.
Yes, on the question paper on the questions, this must at the bottom there's the answer also.
Yeah. So what did you get?
No. I got 93 for my for
So
velocity.
the only
93,
difference is after the
33.
comma. So the only difference is after the comma.
Yes, sir.
That's fine. That doesn't matter.
Oh, okay.
Yeah, that doesn't matter. As long as the approach is mathematically correct, that's fine.
Yes, sir.
Yeah, that's
Okay.
fine. That is absolutely fine. Right. Let us look at projectiles if there are no more questions. Nah, there are no more questions regarding results and velocity. Hello.
No, sir, we can continue.
All right.
Yes, sir. We can continue with projectiles.
All right. Right. Now, did you guys watch the video on projectile?
No.
No.
Yes.
Okay, so this is gonna be pointless then, because everything is gonna be absolutely new to you guys. What I'd suggest is that you guys watch the video on projectile motion. Right. I will tell you which activities to attempt on the activities I uploaded on Moodle. Right. I will tell you which ones to attempt. Right. So watch the video on what is this thing? Projectile motion. Once you are done with the video, attempt the problems I will tell you to attempt. Right. The answers will be on the question paper, so you should know if you're on the right track or not. Right. Also, I'll probably give you 3 problems to do, and then what I'll just do is I'll do the solutions for those and either send it to the group or upload it on Moodle, so you can check your answers. Nah.
Yes, please, sir, because I did attempt the questions on Moodle, but I would just like you to do the answers so that I can see how you're approaching it.
So is this for projectiles?
That's correct, sir.
All right. So you attempted projectiles without watching the video.
I attempted it because I've done info science already, so that is why I attempted it.
Okay. So first watch the video. Nah, watch the video on projectiles.
Okay.
So all of you, make sure you watch the video on projectiles, then attempt the exercises. Nah.
No problem, sir.
So as far as projectiles, just focus on the ones I'm going to be sending to the group. As far as the test will be similar to those.
Okay,
Nah.
sir.
For now, don't waste your
Sir,
time.
for the okay. Yes,
Don't
sir.
waste your time looking at the other exercises. For that is for
So
now.
for resultant, was we only focus on the activities that you gave us now for the test?
See, with what is this? With the results and velocity. If you understand results and velocity, it shouldn't matter which one you get in the test or exam.
Okay.
Shouldn't matter, because, like I said, we have covered everything under the sun. What we've covered up
Okay,
to so
sir.
far, as far as results and velocity, right? You should be able to attempt any and all problems. And I see you got the gist of the principle. Your approach as far as what is this? The method of components. It was much simpler than mine. Right?
Yes, sir.
Which means you are getting the hang of this thing, which is good.
Okay, sir.
Nah.
Yes, sir.
Once you've done like a couple of exercises on results and velocity, it will be like you are repeating more or less the same thing. But
That is true. Yeah, I've noticed that, sir.
just to make sure that you're on the right track, do as many as you can. No need to do all of them, but just do as many as you can.
Okay, sir.
Right. So make sure you go through that video. Once you're done with that video, then you can go through what is this? You can go to beams. There's a video on beams as well. So our next session, which I believe we said Saturday, nah?
Today, yes, sir.
So on Saturday.
So
what time?
What time on Saturday?
6 p.m.
6 p.m.
Yes, because some people work weekends as well.
Okay,
So in fact, no, 5 p.m.
5. Yeah, that's reasonable.
Yeah. Yeah, 5 p.m.
Sorry. If it's that time, can you please record for me the session because I won't be available.
Yeah, I'll record the session.
Okay, thank you.
I'll record the session.
Is
So
this
make sure-
session also recorded, sir?
yes,
Oh, where do you upload?
I'll upload on my channel. So once I've uploaded, I'll send the links to the group. So for yesterday and today, I'll send the links for both the videos or for both sessions
Oh,
in the group.
yes,
Oh, thank you.
yes. So on most of the groups I asked where we gonna write online or in class. I didn't see in Sir's group, so asked that question.
Yeah, I forgot. I'll do it tomorrow.
Okay, sir.
Yeah, I'll send the thing tomorrow.
Okay.
All right. Any more questions?
Not a question,
sir.
sir. The notes that in the very first session where you also sent through the notes that you made. Can you put that also in the group, please?
What notes now? Oh, what we just did.
Yes, sir.
Oh, okay. All right.
Yeah, because sometimes in the video you do a step, but when we can't see the whole equation, then we get lost a bit. Me personally, so because I can't see the whole thing when you scroll up and down,
Yeah.
so the notes is better. Then I can see the whole picture.
All right. Okay. I'll send everything to the group.
Thank you, sir.
All right.
Hi, sir.
Yes.
So tonight there's no projectiles without someone having first watched the
The video.
video on
The
Moodle.
video.
Yeah, it's pointless because now it'll be like I'm teaching.
Oh, okay. No, I see. Okay.
Yeah. It's gonna take longer because most of you guys haven't watched the video. So instead of having an aha moment, it'll be like
Mm.
I'm teaching now. It's gonna take longer.
Oh, I understood.
Yeah.
Okay, sir. So please don't
Okay.
forget about the Meccano.
Meccano is tomorrow.
Oh, is it tomorrow, sir? Okay.
Yes. We'll have a live session tomorrow for Meccano, 6 p.m.
Okay, sir.
All right. Is there anything else?
No, sir.
Okay.
No.
Right. If there's nothing else,